I want to welcome Nobel Laureates, Edvard Moser. He's a neuroscientist at the Norwegian University of Science and Technology in Trondheim in Norway. In 2014, he shared the Nobel Prize in Physiology or Medicine for his discovery of grid cells in the brain and how they provide a neural map of the body's location. The research has memorably been described as helping to unlock the secrets of our inbuilt GPS. Professor Moser, you're very welcome. Thanks for being here. We've lived through an extraordinary and a tragic year, but at the same time, we've seen some astonishing scientific breakthroughs. So first of all, I want to ask you, what has the pandemic taught you about the state of science globally?
Yeah, thank you for inviting me. I think it has been interesting to observe how much science has actually been able to accomplish within a short year. I think that is pretty amazing. So what it tells me is that it tells me two things. First, how much you can actually do if you put a lot of money and resources into solving a particular problem. It's almost like the moon landing in the 60s. You can achieve it if you just put enough resources in. But the second thing I would like to emphasize here is that none of this could have happened if there hadn't been a mountain of basic research in front of this. So this builds on huge amounts of knowledge in virology, in immunology, that allows us to exploit all that knowledge and then generate efficient vaccines and do it. Just know exactly how to compose the vaccine and then generate it within such a short time. That is thanks to all the investments that have been done have been made in science over many decades.
Do you think the record pace of creation and discovery in the last year, does it in some way suggest maybe the science industry and maybe regulators have been a bit slow in the past?
No, I wouldn't say that, because it's really not common that so much effort is put into one project and in such a coordinated and concerted way. So this is what you can achieve with science. If you really take all the funding you have, all the scientists, put them and ask them, solve these problems, please, as soon as possible. However, that is the result of the more explorative science that goes on in the background, where different investigators ask a question, try to find it, and ask another question, and different investigators ask different questions. That creates this enormous base of knowledge that allows us to put things together and actually find a cure when we really need it. So it shows what the possibilities are, but again, this couldn't have happened if we hadn't had the more explorative science that by necessity takes a long time, goes at a slow pace, and not the least, it doesn't always work as you think. Quite often you try something, it fails, you try something else, it fails, and you try again and it works. And that failure, testing, trial and error process is part of it. It's a necessary part of science. And therefore, seen from the outside, sometimes it can appear as if science is slow, but it works. This is the only way it can work, really, because you don't know the answer in advance.
So as luck would have it, the EU has a new research program that is just about to launch. It's called Horizon Europe. It's, I think, 95.5 billion budgets, and it's going to last for 7 years. So if you were an advisor now to policymakers in Brussels, what would you be telling them? What do you think needs to be in that program? Do you have any specific suggestions?
Yeah, so I have been asked a number of times, and as you know, the research budget has been under threat several times for the risk of being cut. And of course, it is very easy on a short-term basis to cut the research budgets because, and that applies anywhere in the world, because research is long-term and you won't see the results overnight. You will just see it in the long term. but that's not a smart thing to do. And I have advocated many times, especially for the ERC, the European Research Council, because that was so much a game changer when it was introduced a little bit more than a decade ago, I would think, because the ERC funds fundamental, groundbreaking research that is not driven by any specific question. It's basic research into fundamental matters, whether it's biology, physics, or whatever. And it is that type of basic knowledge that allows us to solve problems in the world. And I would say the last thing one should cut, because this is really the cutting edge of knowledge acquisition. You go into the unknown and you find unexpected things, and then you can exploit that in the next round to make new inventions or solve diseases or whatever.
Well, thank you very much for chatting with us today, and I wish you luck in your research. And yeah, we can't wait to see what comes out of it. Thank you.
Thank you very much.